Let's look at 1975 IP Physics B FRQ question. In a mass spectrometer, singly charged oxygen-16 ions are first accelerated electrostatically through a voltage V to a speed of V sub 0. They then enter a region of uniform magnetic field B directed out of the plane of the paper. The oxygen-16 ions, that means they're positively charged, are replaced with singly charged sulfur-32 ions of twice the mass in the same charge. What will be their speed in terms of V sub 0 for the same accelerating voltage? And for the B part, when sulfur-32 is substituted for oxygen-16 in part A, determine by what factor the radius of curvature of the ion's path in the magnetic field changes. So because the ions of the oxygen are positively charged, if I use the right-hand rule, I see that the force as they enter is going to be acting on them in this direction. So at the moment when they are entering, they will be in active this direction, so the magnetic field force. And since the ions have the same charge, the work done on them from the voltage formula is going to be equal to the work per charge. So the work is equal to the voltage times the charge. And in this way, the initial kinetic energy, or the work to accelerate the oxygen ions, is going to be transferred to the kinetic energy of the or the work done on the sulfur. So I can say the kinetic energy of the oxygen is going to be equal to, so the kinetic energy of the oxygen is going to be equal to, or is going to be transferred into the kinetic energy of the sulfur. So I have 1/2 the mass of the oxygen, velocity of the oxygen squared is going to be equal to 1/2 twice the mass of the oxygen for sulfur, and the velocity of the sulfur squared. So if I cancel 1/2 from both sides and mass of the oxygen from both sides, then I get that velocity of the sulfur is going to be equal to V sub 0 divided by the square root of 2. So that will be my answer for A part. And for B part, again, I have to calculate the by what factor the radius of the curvature of the ions in the path with the sulfur will change. So I have to calculate the radius of the sulfur and the radius of the oxygen, and then I will compare them. So you know that there is a circular motion right there, so I can set up that the force, the centripetal force, is equal to the magnetic field force. So I have magnetic field force is equal to the centripetal field force for both oxygen and sulfur. So that is centripetal field force. So I'm going to use this equation for both to find the radius of sulfur and the radius of oxygen. So for the magnetic field force acting on the charge, I have QVB. Charge is the same, and the velocity of the oxygen, and that is equal to centripetal force of the oxygen. So mass of the oxygen, then I have velocity squared of the oxygen over the radius of the oxygen. So now I can cancel one of the velocities, and I have the radius of the oxygen is equal to M sub 0 V sub 0, or oxygen divided by Q times B. And then for the sulfur, I have the same charge of the sulfur is the same velocity of the sulfur, which is V of the oxygen divided by the square root of 2. And then I have B is equal to mass of the sulfur, which is twice the mass of the oxygen, and I have the velocity of sulfur, which is V of the oxygen divided by the square root of 2 squared, and all of that divided by the radius of the sulfur. It's mass v squared over the radius, right? So here I can cancel one of the v sub 0 over square root of 2, and then I can solve for the radius of the sulfur is equal to, and I have 2 over the square root of 2 mass of the oxygen, velocity of the oxygen, divided by QB. And if I compare these two guys, then I see that the radius of the sulfur is going to be 2 the square root of 2 the radius of the oxygen. So that will be my answer. Thank you for watching this video, and I will see you in the next one.